Hey, this is Rich Niemiec, and welcome to the 18C new features. I'll also have a little 12C R2, and just let me know, Francisco, if you have any questions. Francisco will feed those over to me. But first of all, I'm happy to be here. Happy to be in Australia last time. Next time, just invite me over. This talk is going to be mostly about the acronym WIN. The acronym WIN stands for W-I-N, What's Important Now. What's important right now? What's important now for you to succeed? That's what this talk is about. First of all, 12CR2. Some of the new features that are out there. Last time I did some 12CR1, we did some 12CR2. I did that with Charles Kim. This time I'm going to look a little bit deeper. I'm going to touch upon 12CR2. I'm just going to give you a couple of examples, and then I'm going to jump into 18C, and then we'll take a little bit longer there. I'm going to show you a little bit about autonomous database and just kind of where things are going and how the future is going to play out. So it's about what's important right now. Right now, what's important is 12C. If you text cloud to 444-999, you can win a cloud book. And if you send an email to hello@viscosityna.com, we can get you the slides. And of course, I will also get those to Francisco as well. So keep that in mind as well. But you got to look at, what's important for you right now. The thing that's important right now is you're probably using 12C. So what's important now is make sure you implement some of those new features. You're going to be shortly into 12CR2. Make sure you implement those that are advantageous to you. And then 18C, how to prepare for that, when to move to that, we're going to talk about as well. And once again, you see how you can win a cloud book, and you can also, or win a cloud book, online cloud book. They'll give you a code for that. And then also, @RichNiemiec on Twitter is on here as well, and I usually give my up-to-date information on that as well. Special thanks. I think the person we've got to thank the most is, of course, Francisco. Thank you so much, Francisco. Appreciate you helping me tie into this. And everybody in Australia treated me so well when I was there. I would always say yes to Francisco when he wanted me to present something. A little bit about my overview. I've done a lot of different things. You could see some of the books that I've written. You could see some of the other awards. The short answer, though, is I started out as a DBA, and over time, I worked into different things. And now I like to show DBAs, where things are going now that they're here. What do we do as a business? This is Viscosity kind of in a nutshell. You can see that we do pretty much professional services. You can see zero downtime migrations, performance health checks, professional services, DBA services. We do Oracle Cloud Infrastructure. You name it on the professional side. All things Oracle, but different from other companies, I think we look to be a trusted advisor. You can see we enable business transformation at a time when you must transform to succeed. And it really does all of the infrastructure, not just Oracle, Exadata, Hadoop, Kafka, ASM. You can see DataGuard. You can see all the different books we've done. VMware, we also have several VMware experts as well. And there's just the last book that I put out, 12C Release 2 Tuning. I think in 18, that's probably 99% of it's in there, and the rest of it's in this one. And there is also a query tuning book. I don't mention that a lot, but you can see that on the right. That's a very small book, and it's just kind of on the developer side. So what are we going to cover? We're going to cover what's important now. What's important now? Some of the 12CR2 features. Multiple indexes on the same column. In-memory virtual columns. Approximate Query. Pluggable Databases. Adaptive Query Optimization. Runaway Query. Security. Exadata. In-memory. Partitioning. And then we'll look at 18C. And I'll go through those when I get to that. And then we'll look at Autonomous Data Warehouse Cloud. So what's important? If we look at these topics, in-memory is important because that's where Oracle's focusing. Speed matters. Approximate Query works because you're doing a lot of BI. This might make that a lot faster. Pluggable databases are important as you move stuff to the cloud, share pieces of data with other organizations within your company or with other companies that are business partners. Runaway query management, so nothing ever stops your system. And then into 18c, we'll look at more. And some of the online features, why? How does a manager measure a DBA? And the answer is the amount of time the system is up during operating hours. You know, Amazon went down on Prime Day. That wasn't a good thing. It made headlines. Then we'll look at what you can implement on 18c and maybe which databases you might put in the Autonomous Data Warehouse Cloud. Why do I like to use Oracle? And the answer is they like to be first, and I like to be first. First 32-bit, first 64-bit, first client server, first XML. Oh my gosh, we're at 64-bit. We can go to 8 exabytes or 8 million terabytes of data, but guess what? Oracle can get there, but the hardware can't get there back in 1995. So what did Oracle do in the latter parts of 2000? The last 10 years, they bought a hardware company and started accelerating the hardware world just like they had accelerated that software world. And now all of a sudden you can see all the different products they put out since then. What is Oracle doing now? They understand the DBA is overworked, overburdened. Let's build autonomous for those smaller databases and let the DBAs focus on what's important at the main systems that are out there. Also, know the Oracle. Oracle, half the market. All others, fragments. This is how the market has been since pretty much I started at Oracle. And I started at Oracle in the late 80s at Oracle Corporation and eventually moved on to build Tusk. And then now I'm at Viscosity with some of the great product managers I used to know at Oracle that started this company. If you look at Oracle at OpenWorld, how big is Oracle getting? You can see a top picture. They have a lot of, they're starting to build levels down the middle of Howard Street near Moscone, and their appreciation event is now at AT&T Park. So they need an actual sports event to actually keep all the people in for their major event. If we look at the market, overall IT spending, flat. But cloud investments, 44% growth. So what's important to Oracle now? I want to be where things are growing. Now, overall IT, that's the bulk of what they have. But the cloud is coming. It's coming maybe as a hybrid cloud initially, which is some on-prem, some in the cloud. But the real elephant in the room, which is that unavoidable issue, is what about a DBA? What happens if the database is in the cloud? Does my job go away? USA Today had 10 happiest jobs in America. Not just a DBA, but an Oracle DBA. And still DBAs have this, go away or I'll replace you with a very small shell script. I'm not even going to replace you with a shell script, but a very small one. So sometimes DBA stands for don't bother asking. And so people want to move to the cloud so they have somebody, maybe a little more control over what they're doing. But they really still need a DBA to manage that cloud infrastructure, to manage what should be in the cloud, what shouldn't be there. When I look at the cloud, there's Amazon, there's Google Cloud, there's IBM, there's Azure, and there's Oracle. And all the rest are probably going to get acquired by one of these over time. Now the vendor looks at the cloud and says, oh, you go on the cloud, it's beautiful. How great does this look? The birds are chirping, the butterflies are flying, and everything is great. Then I go to the cloud and it's a very steady path that they want me to go on exactly. And if I get off that path, maybe I wander onto some train tracks and bad things might happen. Sometimes they want me to move quickly. And I look at the cloud, it's kind of like this, or I might go off the cliff. So you got to be very careful when you look at that migration. But a few years later on the cloud, people that I know that have gone to the cloud who initially said, I did not like that. Oh, it was very hard. It was very regimented. I had to go a certain path. Once they got there and understood how to leverage the cloud, it was the best thing they ever did. And they loved it. They were like, it really was everything they said, because now my business customers are asking for things they never asked before because I couldn't do them. I wasn't on the cloud. It wasn't possible. Where can you use it now? And this talk isn't on cloud. This is kind of extra material. You're like, oh, I thought it was on 12c. Well, 12c is in the cloud. So is 18c on ADW, or Autonomous Database Warehouse. But some of the places you might try it out if you say, you know what, I need to get better at the cloud because I want to be the DBA that manages the cloud and on-prem. You know, it's just a database somewhere else at the end of the day. A good place to start is DR on the cloud. Why do you put your backup in the cloud? First of all, it's encrypted in the Oracle Cloud, but it's somewhere else for DR. You could also put business critical workloads in the cloud. See if they scale. You know, I only have a small server here, but what happens if I put it on Exadata? How about dev test? I want to test something. I don't want to buy a piece of hardware and then I don't need it because I'm done testing. Let's put it in the cloud. Ramp it up when I want it, shut it down when I don't want it. And then, of course, things like I might migrate all of what I have eventually, if that's a fit for my company. Oracle, though, is letting you try it now. Cloud.oracle.com/try it up to 3,500 free hours. And you can even use that for Autonomous Data Warehouse, Rebello, you name it. Bare Metal, Exa, depending on how much you use. You have to stay within the amount that they give you. Exa, I'm not positive on that, so let me hold that back. But Oracle will often give you cloud credits to play with large things where you can test out your system as well. But I just wanted to show you how easy it is. You go on the cloud, you sign up, all you got to do is say create a service, you tell it where it is, how big it is, maybe 2-3 more screens later, and a little bit later you're on the cloud. I have 2 services here. I built 2 platform as a service, or database as a service rather, with 17 CPUs, 245 gig of memory, and so on. It's very quick. I also could do something called Exadata Express. And once again, this is from my Twitter, @RichNiemiec. When Larry announced this, I tweeted it. So if you weren't sitting in Moscone Center hearing this, you would have got it from me on a tweet seconds after he announced it. But Oracle announced 12CR2 first, for only $175 a month on the cloud. Fully managed by Oracle, $175 a month, with all database options for Oracle Enterprise Edition. So very quickly we see Oracle wants to be on the cloud first, and that's one reason to test things out as well and have your dev test there so you can be prepared for what's coming, even if your production you don't put on the cloud. You'll also find in Exadata Express it looks very similar to database as a service. 2 services, so many CPUs, so much memory, very, very similar. So it's same look and feel as what you just saw. When I go to automatic data warehouse cloud service, you'll also find out it looks very similar as well. Oracle calls that actually ADW now, Autonomous Database Data Warehouse. Autonomous Data Warehouse, sorry. But it's part of the Autonomous Database. But you can see that it's a very similar look and feel. So the more you do on the cloud, the more you're going to be ready for Exadata Express. You're going to be ready for ADW. And here's just an example where Oracle says you could do this with Autonomous Data Warehouse, $300 in free credits. Well, that's actually higher now, which you saw in the earlier slide. Okay, now let's scale back to 12c. That's enough cloud. And I'm not like Oracle where I'm going to force the cloud on you. I'm just telling you because I think it's important to your job to be on the cloud as well and understand what it does. But now let's look at upgrades. The CEO is very interested that you put on the new version, maybe 12.2. It's going to give you the milk. CIO's invested. He'll throw in a couple eggs, but the DBAs whose bacon is really on the line at the end of the day. So keep that in mind. The new version comes out, life is good. It's up and running, 12.1. You can see all the different parameters here. And notice in the right corner, I'm going to have a 12c here when it's 12.1. And here's just cloud control. I could see that I have several pluggable databases up, which also came out with this version. And let's go to 12.102. I'm going to put a logo with a 12c and a 12.102 here, if I have that. And that's when in-memory came out. And you can see this little in-memory area. And I always ask people, what does that mean? And they're like, oh, it means I could push, columns of tables or whole tables in memory. And I'm like, no. It actually means you just bought something. And if you enable this, make sure you understand that you might have bought something. But by default, it is not enabled. In-memory size, as you can see here, is set to 0 by default. Some other huge improvements that I think you have to remember in 12CR2 is object names for users, roles, tables, columns, indexes. No longer 30 bytes, now 128 bytes. Why is that? And the answer is Oracle wants you to migrate from other non-Oracle databases that maybe are 128 bytes. And so they're giving you that flexibility to do so. Certain things, specific to Oracle, like table space or pluggable database, still 30 bytes. Also, in 12CR2, you could have up to a 32-character bar chart, which is default on the cloud so far. I don't know if that'll change. And you can see an example of create table, APAC Oracle DBAs are super cool in Australia in 2017. What? 2018 make that? Hopefully this doesn't mess anything up. Francisco, you better send me a text if I have messed up the thing, changing that in 2018. But you can see I have ultra long names, and you can see my other Oracle database 12CR2 is available. See how long those columns can be. So you can be very, very descriptive if you want to be. SQL Plus also now has a history command. I think this was an enhancement asked for back in version 6. Let's see, they finally got it there. Notice this is now 12C release 2. So I showed 12.1 logo for 12.1. And Francisco says, yes, everything's okay. Thank you for that confirmation. And you saw 12C with the 12.102. And now this is my 12.2 logo, 12.2 and higher logo. So this tells you that this is only on 12.2. But I could set the history on, set it to a certain number of commands. I could show what it's set to. I could run a help. But most of all, I'm going to have a list of commands, and I'm going to either run one of them, or I'm going to delete one of them. Maybe I'm going to edit it, one of them, or I'm going to clear it all. And you can see Nitin Vengolakar, who his tag name is DB Cloud Shifu, is on his Twitter also. But he has some nice, he has a nice paper on this as well. And you can see select name from $, database, and then I select from $, instance, and then I check the history, and I've got 3 commands. Maybe I delete the third one, but I run the first one, and you can see what the database name was, and the first one was Merit, and you can see it just runs it and gives you the output. So very, very nice new feature that I like. Something new as well, and you can see this is in 12C, even in 11G was the virtual column goes all the way back to, but in 12.2, they added an in-memory virtual column. So if you're familiar with this. So you create a virtual column, maybe employee number, salary, yearly salary, and you have a monthly salary, but you say yearly salary is generated by the monthly salary times 12. So this is a not physically stored, although you could put an index on it. So now when I do a select star, it shows that yearly salary, but it's not physically stored anywhere. That's a virtual column. But the main focus I wanted to show you is in 12CR2, notice the new logo here, is now I can have that in memory as well. I could say in memory virtual columns, enable that. Then I can alter a table in memory, and that'll put the virtual column in memory. Or I could specifically just put the in memory, put that yearly salary virtual column in memory. And it puts it in a place called the in-memory expression unit. Now Oracle puts columns and tables, stuff like that, in the in-memory compression area, compression units area. And I'm going to show you a diagram of this a little later. But this puts it in the expression unit area. And it also puts things like JSON. So virtual columns from JSON objects are loaded into that in-memory virtual column, and it goes also in an area of that in-memory expression unit. And in 18C, that's further expanded to support indexing of JSON. Greater than 64 characters, also supports spatial JSON. So as JSON becomes bigger and bigger, Oracle has come out and started to support that, not just in the table, but in memory as well. At 12C, you could put more than one index on the same column. I'm not going to go through this because it's kind of an FYI, but you can see I have multiple indexes, a bitmap, normal index, reverse key, unique index, all on the depth node column. You also create a function base, but that's really not on the depth node column, so that could be on at the same time as the bitmap. But that's something, so maybe in the morning I'm going to use, a reverse key index, but at night when I run some data warehousing report, maybe I want a bitmap index. And maybe at year end, maybe I want just a unique index or a normal index. Another feature of 12CR2, Approximate Query. Started in 12.1, but I'm going to show you how it's enhanced in 12.2. And what this does, let's see, sorry, stuck at long name identifiers. What? Oh, okay. So let me go back, hold that thought. Right. You're like, gosh, I've missed some slides. And that's because I'm going to turn this off. Hey, how's it going out there, guys? What's important? What's important now? WIN. And here I am at the Viscosity offices. You can see I'm in the conference room here. Okay, hold that thought. And now I'm going to share just this screen. And hopefully it's now on Approximate Query. Can you see Approximate Query now? I'll have to see what Francisco says, but I'm going to go back a few slides so you can see the other ones that we passed. There was your long name identifiers. There's your SQL plus history command. Francisco, let me know if you can now see a different slide other than long name identifiers. Yes, he says. You can see these are the history commands I showed real quick. Here's how to run them. Select name, 2 queries, and then I'm going to run that first command that was up here listed in my list. Isn't that nice? Okay, so I'm not going to fix any more slides in case you're wondering, Francisco, because then we'll get stuck there. And then this is the one I just talked about with the virtual column. I've created yearly sal, which is monthly times 12, a generated value. And when I do a select star, it shows me all the columns included that it generated, but it's not stored. I can build in-memory virtual columns, and this is just an example, and you can download that examples, and I can put JSON also there. And it's, as I said, in the in-memory expression unit area. And multiple indexes on the same column. I just brought this up, and this is just an example where I've created multiple indexes. I always have to make all of them invisible other than the one I'm using. In this case, I'm using the bitmap, and normal, reverse, and unique are all invisible. And I might make one of those, I might make bitmap invisible and then use the reverse key index for a different kind of report or something like that. All of them have to be maintained though, so keep that in mind. That's in 12.1. Okay, now we're caught back up. So Approximate Query, what does that do for me? Any result other than the approximated value is 100% accurate, but the approximated value is within 97% of what I specify with 95% accuracy. So if I wanted the people with $1 million in sales, it'll give me those that are 97% of $1 million at the minimum, and it'll be 95% accurate. So I'm not going to get some department that only has $100 in sales, obviously. And you'll see why I want to do that with the speed increase. Now this, just to let you know, the beginning of this was introduced in 12.1. So I could do account distinct and do an approximate account distinct in 12.102. This started. And Oracle backported some of this. So some of this you'll see in 12.1 that wasn't originally there. In 12.2, now I could just toggle on approximate, so everything is an approximate distinct when I do a distinct. That's going to save a lot of time, but it's only an approximate. Keep that in mind. Also in 12.2 only, I have a bunch of other approximates, approximate median, percentile, aggregate, so on. You can see those. I could also have support for materialized view and query rewrite I did not have in 12.1. In 18c, we're going to see you can do a top and approximate aggregation as well. Another thing we saw introduced in 12c release 1, and you're going to see it enhanced in 12.2, is pluggable databases. So maybe I have an ERP system, I have CRM, I have data warehouse, and I can keep those separate and also keep them separate from my installation of Oracle. So my installation of Oracle is kind of my clean version of Oracle. And now I can put my actual data for various applications in what's called pluggable databases. So if you don't use pluggable database now, currently you have non-CDBs. This is the original kind of database, not a container database, not a pluggable database, just a non-container database. And then you have, as you go to containers, you have a main container database, which when you install Oracle, it builds this root database and has a little seed database, kind of a mini database that's read-only that you can copy things from and kind of play with a little. And then you have pluggable databases, and that's where you're building something that, that you're going to maybe move to somewhere else. Now, if you have a non-CDB now, you can build, Oracle allows you, without buying multi-tenant option, you still get the option to have a container database, but only with one pluggable database, not counting the seed database, of course. And that pluggable database is going to be your main production. But what that's going to allow you to do, and this is why it's important, is first of all, non-CDBs deprecated. So Oracle's moving away from that. The other thing is now I could start to move that pluggable database in and out of the cloud if I want, or move it between systems or things like that. And we'll see how easy it is to work with pluggable databases in a minute. But the main reason is I want to consolidate lots of databases and use and share those resources. That's the reason why people move this. Patching and upgrading, there's also big benefits as well. Things like RMAN you can do at a pluggable database level. We're going to see that as well. It could be a big advantage. Oracle had a paper, though, consolidating PDBs. And the difference, what if I had 252 PDBs or all in a non-CDB, 252 non-CDBs, they all have their own container other than, instead of being multi-tenant. You could see the throughput with the non-CDBs much slower, about half as many transactions compared to the pluggable databases. And the pluggable database is a little bit slower, but then go and look at the memory footprint. It went from 1.7 gig down to only 200 megs. So they substantially reduced the memory, and they still are getting more transactions. And you can see they don't use as many storage IOs just because you're sharing resources. And the CPU is about the same. Slightly slower on the response time, but you could add more memory if you wanted as well. You can see there's a huge benefit there. And the link is there as well if you download this talk. The next, just kind of FYI, just to show you some commands for pluggable database. Check your database. Is it a container database or is it a non-container database, not using pluggable databases? This will tell you, yes, this is a container database. I'm using multi-tenant. Query the PDBs. You can see PDB seed. That's only read-only. You can see the other ones that are out there. But also clone a PDB, and this is the biggest advantage of using containers, because now I could just create a pluggable database, it's PDB2 from PDB1, maybe put it in a different place, maybe change the prefix even from what I pulled it out as, change the storage, whatever I want to do. I could pull it over a link. In release 1, the source had to be read-only. So I had to set that to read-only, then I could do a clone. In release 2, I do not have to have a read-only source, which is great. And then here's just an example of unplug it into an XML file. So what happens when I unplug it into an XML? Literally what I'm doing is I'm pulling out the XML file or this metadata, and then I'm going to ship that to somebody along with the physical files, make a copy of those to them, and then they can import it again. So what happens there? Well, I'm not pulling all the data out of the database. I'm giving them the data files. And then I'm giving them a little meta file, XML, not very big, that they need to load in, to their system. And now they'll have that same pluggable database in their system. And here's just an example of drop pluggable database, including data files as well. You can also set pluggable level parameters. So DB cache, shared pool size, as long as I keep them less than 50% of all resources, so the main container has to have half the system. The rest of it can go specifically to pluggable, so I could give one pluggable database more than another. Some new features, I can do a PDB refresh. I can do flashback of a PDB. I can do a lot more PDBs. Used to be 252, now it's 4096. And there's some other things there. But basically, one of the benefits of Pluggable Database, I could take that Pluggable Database, move it to the cloud, and I can also do a refresh every 60 minutes. So as data is changing over time, you can see some data has changed there. It will move it then to the cloud to keep that consistent. And then I can build, snap clones from that clone. So I'm using a refreshable PDB here. It really is quite powerful. And that makes it easy, if you look at it from Oracle's perspective, you want to move to the cloud, how hard was it to move there? Well, they're going to make it even easier because now they're going to give you a PDB relocate. You've got an on-premise CRM. It's going to do exactly the same thing. It's going to clone it, but then it's going to move it, and it's going to switch the users there. So I can now actually relocate a PDB to the cloud. I can move it back as well. I could flash back just a PDB, flash back Pluggable Database to an SCN number, very similar to how you do a flashback now. Something new in 12c, our release 1, is adaptive query optimization. I'm going to show you some cautions a little bit later on this, just so you know. And then you'll see some enhancements in 12.2. I'll let you know those right now. So Oracle and 12CR2 continuous adaptive query plans, where I can use a recursive with different input values compared to the previous iteration. So that's kind of a new benefit. And then in 18c, adaptive will actually do bitmap index pruning. But the main things it does in 12.1 is it does something called adaptive plans. So a query may be running, joining two tables, and maybe it's doing a sort merge join. And as it looks through the records, it says, the stats aren't right on this. It shouldn't be a sort merge join. And it will change it to a hash join in the middle of running it based on what it's seeing. Or it could change parallel as well. It also can relook at the statistics. And I'm going to talk about that in a minute. Let's look at query optimization where I'm running a nested loops. It's got a statistics collector, kind of seeing how this is going. And it says I'm looping through, should be 5 times. Maybe I'm going to loop through 1, 2, 3, 4, 5. Oh, whoa, 6, 7, 8, 9, 20. Oh, the stats must be bad. I should have done a hash join. So it changes it because that statistics collector exceeded some threshold where it's really better to do a hash join. I just didn't know it when I started this query, but after I went in it a while, Oracle adaptively changed it for me. So Oracle's tuning queries. And if you wanted to check this, you could just do an explain plan. It says, oh, what am I going to do if you run this query? I'm going to do a nested loops. And then you could do a dbmsx plan after you run it. So what did I run on this? A hash join. So I can see the initial, what it was going to run, and then what it actually changed to at the end. Now on the statistics. Adaptive plans were nice, changing my nested loops to hash join. Love it. Worked well. But adaptive statistics did not work so well where it was reusing those statistics. So what happened is Oracle in 12.1 had optimizer features enable set to true. And it said, what I really need to do is split that into 2 parameters. I take it back. Optimizer features set to true. Optimizer features enable set to the version you have. But optimizer adaptive features, I set to true in 12.1. In 12.2, it splits it into 2 different parameters. So instead of setting it to true, it builds a plans, which people like those adaptive plans, so they set that to true by default. And then adaptive statistics, which didn't work for some people, so it says, I'm going to split that out as a separate parameter. I'm going to set that one to false as a default. And you could actually backport this and you could see the patch. And the reason I'm spending a lot of time on this is as we've done upgrades, this has been one of the key things that we've seen that you have to fix. So keep that in mind. And that's also in my Twitter at Rich Niemiec if you want to find it. Runaway query management should always be there. It's been there since 12CR1. CPU is exceeded, physical I/O is exceeded. I could build a resource plan that says switch the group, kill the session if they're exceeding 60 seconds of CPU. switch the group to some other group that's doesn't get as many resources after they exceed a certain amount of I/O. So there's a lot of things that you could do to ensure one query does not kill your system. Oracle also at the resource manager side allows you to limit the memory for a given PDB, or set the minimum amount of memory it gets and limit the top level memory, as long as, once again, this doesn't equal more than half of the memory. Very similar to the other parameter. And then database security. Some people say, oh, this database I use, it's as good as Oracle, and they have maybe one of these security things in their product, but they don't have all of these that Oracle's been building for 40 years. In 12c, release 1, they've added multi-tenant security, encryption in the silicon. In 12.2, they've added tablespace encryption and fully encrypted database. We'll see some of those in a minute. And here it is, TDE encryption now available, including system, sysaux, and undo. And here's just an example. Alter sysaux, encryption online, encrypt it, and then the example of decrypting it. You can see in 18c, you're going to also be able to encrypt sensitive credential data stored in the data dictionary in these internal system tables. The other thing to remember, and I put this in there just because I think it's so important as you look at something like Exadata Express or some Exadata in the cloud, is that there are a lot of features built into this Exadata that when Oracle sells you the cloud, they may give you these just because you bought a certain cloud service. So keep that in mind to price things out. If I did this myself, well, maybe it's less expensive than the cloud, or it's similar to the cloud, but I didn't have all these features maybe on premise. So keep that in mind and make sure you take that into account as you price it. But Oracle, it doesn't matter to them. You could buy your own Exadata, that's okay. Private cloud, on-prem. Or you can put it in the public cloud, okay, public cloud. You put it there too. Or maybe you could put it on site and we'll manage it still, similar to how we manage the public cloud. Oracle, it doesn't matter to them which that you choose, but you're really going to get the same Exadata in all three places. So keep that in mind, that there's a lot there. Now, if I buy a private cloud, that might be a capital expenditure. CFO doesn't always like that. Whereas if I buy it in the cloud, it's going to be operating expenditure. And that's why Oracle gave you, for people that have certain restrictions on security, they gave you one in-house that can still be on the OpEx model. If you look at CPU over, every 18 months, it doubles, Moore's law. But hard drives have not done that. And so flash is kind of filling that gap where hard drives, they haven't been flat. I mean, they're a little faster. Sometimes they're slower, where they try to sell you slower drives, SATA drives. So it could actually even be slower, or it could be a little bit faster, but it's nowhere near the advancement of CPU. And flash really fills that. Look at Facebook, leading tech company, a lot of flash. Amazon, leading tech company, a lot of flash. That's what I see. Google, leading tech company, what do I see? A lot of flash. How about your system? You say, well, I can't afford that data center. Well, how about just put it in the cloud? Use Oracle's flash. This is how we see Google. They can't get into my business, but this is how Google sees us. Yeah, I could take over that business if I wanted. Why? Because they're using superior hardware. They're leveraging technology. Is your company leveraging technology to be a leader? How about in-memory? There's going to be a quick FYI on in-memory, and then we're going to go into 18c. We talked about the in-memory area here, if I have it turned on. But right now I have a buffer cache. I could look at an individual row in memory, but a lot of times people do analytics where they want a whole column. Sum up the salaries of everybody, sum up the number of sales or something like that. So they want a whole column of information, not a row. So Oracle says, you know what? We're going to give you the buffer cache for those rows, but we're going to give you a new cache, an in-memory column store separate from the buffer cache. It's going to be in memory as well. It's going to be compressed, and you're going to use that for analytics, where I can put a column in memory or a whole table. So here's just a little example. Let's say I have some data here, and I run a query, insert, or an update with specific values. Well, maybe I'm updating. It's kind of good to do that at the row level because I'm hitting just that row or hitting just a couple of rows. What happens when I run something that includes all rows? Now I've done everything because I have two codes here. You can see them here. Now it includes every row. What if I took just those two columns, which are very small, by the way, and when I do compression, they're going to compress tremendously because there's a lot of duplication there. So they might say the ends are from, this row to this row. Make it even smaller, but it takes that, turns it sideways, so that now when I run that query, it's just looking at those columns. That's looking at them in memory, and it's looking at them that are compressed. So it's not a little fast, it is unbelievably faster if you need that. What can I put in the end memory? What can I put in memory rather? I can put a table, put a column, table space, partition, subpartition, materialized view. Here's an example, create a table in memory, alter a table in memory. Now notice, once I enable that, it's not populated yet. To populate it, either I have to do a full table scan so that whole column gets pushed into memory, or I need to populate it. It takes a little while to do that. There's a lot of queries to see how far it's populated and so on. Now if I set it up with certain, I could also set it up to populate when I start up the database as well. There's alter a table in memory. Now it's in memory. I run a query, do an explain plan on it, and I can see that my explain plan, yes, it has used the in memory. I can also change the compression to higher or lower levels, depending on how often that data is updated. I could also make a certain column not in memory. There's all kinds of flexibility here with how I do that. And then this is just how Oracle internally is putting that in memory into this in-memory compression units. And then also if I use things like virtual columns or JSON, it puts this in this in-memory expression unit area. I also could do joins in memory. So I could build join groups, create a join group between stores and sales on store ID, and I'll store those together. Those columns will share a compression dictionary, which makes my joins now substantially faster. Other things with 12CR2, a lot of online features. Alter a table, move online, move partition online, move subpartition online, move online, compress the table, update the indexes. What does that mean? Well, it means that it will also do automatic index maintenance as it's moving, and with update indexes, I can use those indexes while I'm moving them or doing that update online. One of the big features that not a lot of people use is Big Data SQL. Hadoop, maybe not so very secure. A lot of people write about how it's not very secure. Well, how do I make it secure? Well, go out of Oracle into an external table where that Hadoop data store is. And now I can securely do my security through Oracle as I go into that data source using Big Data SQL. And I could also do that into NoSQL as well. And here's just an example, where I have Oracle, and then now I can put it into this external table, but now I can go one step further and put it in memory as well in 18c. So external tables, and I can also partition it as well. So external tables used to have limited things I could do because it's outside the database. Now I can do it, partition it, and in memory. And if you think of your alert file, wouldn't it be great to take your alert file and just have an external table go to it? So you could just do queries against it. Available now. Other things, memory jobs, heat map, all kinds of other features here. A lot of masking data redaction for security purposes. If you're a beginner, truncate table cascade. Tell your manager you learned that one. That'll scare them. Or even better, in 18c, How about use Cascade with dropping ASM file groups? Wow, have a heart attack. All right, now let's jump to 18C. We're about halfway through, and the other half I have is 18C and a little bit of ADW. So Oracle 18C, every new release is yearly. So Oracle 18C came out in 2018. Oracle 19C will come out in 2019. Oracle 20C come out in 2020. So first you have the yearly, then you have a release update on that 18C, and then you have a revision to those release updates. And I talked about this in my Twitter very early before it was announced. And the reason why is it was seen through various things that things were getting fixed in 18.1. So we learned that maybe 18.1 is the next database. Another thing that's very good, I saw this at the ACE Director update, but release updates are like bundle patches, and you can see what the release update is doing. You know, security fixes, but also things like regression fixes, optimizer changes, emergency one-offs. Whereas release update revisions are only a subset of that, kind of like PSUs. You know, and you can see the different things that it updates, security regression primarily. So if you look at it, you know, you have 18.1, then you're going to have 18.2. So they won't have an 18.1.1. I'll go straight to 18.2. Then they'll have an 18.2.1. So you're going to get the different revisions and the different updates to those revisions. You can see all the different versions that you could end up having at different times. And just to let you know, production 18 or 19, they could come out in January, they could come out in December as well. Just come out a month early, they've said. And here's an example, you know, with RUs and RURs. So maybe in 3 years, maybe you're running 18, 19, 20, you know, what's it going to be? I'm not sure because there's so many releases out there. And the answer is, look at this chart. Next 3 databases, what about lifetime support? So first of all, something very important in this graph that you might look at is, you know, 11.2 is about to be desupported for it, you know, where it waives support at the end of the year. So a lot of people are going to be moving off of 11 at the end of the year. And then 12.1, not so far. 12.2, pretty far. So if I want to jump from 11 somewhere, I probably ought to want to go to 12.2, so you can see how far extended support goes here. And do I want to jump to 19? Yeah, I might do that because there's some features, or to 18 because there's some features, but 19 looks a whole lot better. And the reason why 19 is probably this long-term support release is probably because it's what maybe would have been the terminal release of 12.2 before they started this new release cycle. But the benefit of this release cycle is I'm going to get a lot of new features that I wouldn't have got until the next version in 18 and 19 and 20. So let's look at some of those. So in 12.1, we saw the in-memory column store. In 18C, now I'm going to get an improved in-memory column store. And it's going to improve non-volatile memory support. So non-volatile memory is like, it's flash memory, but when you turn it off, the contents are not lost, like flash. So NVM, some people will call it, is much, much better for that reason. And also for IoT, Oracle is making it so it will ingest data from IoT devices much faster. So maybe something's taking the temperature, you know, every millisecond or something like that. It's creating a volume of inserts. Oracle's making these much faster. So 21 million inserts in a second on a 2-second server. Gives you a feel for how fast this is getting. And the way they're doing this is putting it into a memory buffer, and then they do something that drains it, and they have these background drainers. They're putting it in there. Also in 12C, we saw containers, you saw pluggable databases, main containers, and so on. In 18C, now they're going to leverage those. You know, you say, gosh, I didn't want to go to multi-tenant. Well, now you're going to see a lot of reasons why you want multi-tenant. One of them, and maybe my favorite feature of all, if you followed me on Twitter, I put this one out there very quickly, was Snapshot Carousel. So I have my maybe production PDB, When I build a refreshable clone, Oracle often calls that just test master, it will create snapshots off of that. And by default, it will create 8 of those. So you can see it's taking a snapshot. It's doing one Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then Monday, just so I have kind of an overlap there. Any of those given snapshots that are happening during the week, I could take a clone off of there because it's always a full snapshot. This is a full PDB. Doesn't need to be materialized if you're familiar with this. It is a full PDB copy. And you can see I can have little snapshot copies of those as well off of that clone. If you want to look for a given PDB, this tells you how many PDB snapshots it's going to take. Just a query that does that. I could also set it to 7, set it to 0. If I set my number of snapshot carousel to 0, it will drop all snapshots. So if you want to get rid of them right away, that's the way to do it. I could also set the max number of snapshots as well. I can change how often it does it. You know, by default, it's doing it once a day, but I can make it a whole different amount. I can do it every 2 hours. There's every 120 minutes and so on. This is just an example of how to find what it is currently. By default, it's a day. I could also, maybe I have a big data load. Let's just do a snapshot before and do one after. Notice I'm not naming it to anything. It's going with this snapshot carousel within that framework, and it's giving it a name. And there's just an example of dropping the before snapshot now that I know everything's working okay. And then here I can look and see what kind of snapshots I have out there. And you can see the names that it generates, some of those system generated names. Important note though, PDB snapshot uses what's called a using snapshot. And this is a full PDB, as I said before. Now, using snapshot creates a full PDB, but if I do a snapshot copy, that also has a dependency on the underlying storage based on this, how this is done. This talks about it a little bit, and you must materialize that to make that a full PDB with non-sparse files. And there's an example for how to do that. That's something different, just to let you know what I wanted to discern between the two things. The snapshot carousel is not a snapshot copy. 18c will add ASM split mirror clone PDBs in addition. Also in 18c, and I forgot to say when I do 18c, I have this little 18c logo here. Per PDB switch over, this reverses the role between some refreshable clone PDB and the primary one, switches the two around so that now the refreshed clone becomes the primary and the primary becomes the refreshable clone. And I'll show you how that works here. So here's an example. Maybe I'm creating a red refreshable clone that's refreshing from CDB1 to CDB2 link. You can see here. It's taking it from 1 to 2. So this is the clone. And then the other one, I'm using this to link and I'm building a clone back to 1. So now I say, you know what? I'm going to change this gray clone around. I'm going to go this way instead. So alter pluggable database refresh mode every 2 minutes from gray, but switch over. I'm going to go the other way now. And let's alter that pluggable database over to read right. Now that's my primary. Very, very powerful. When we look at pluggable databases, Oracle building them out in release 1, making them better in release 2, making them spectacular in 18c. Now let's look at 18c. So right now, you've got a great analytics engine. You can go into data, Hadoop and big data SQL, things like that. But now we're going to see within memory for external tables, now that Hadoop data set is much faster than it was before. We'll also look at a couple of other things online, polymorphic tables. In-memory external tables is my way to now take that Hadoop data source, put it in an external table, and remember I can partition that now as well with 12c release 2, but with 18c now I can say in-memory columns. So now I have in-memory external tables. Now I'm putting that Hadoop data into memory. And the other nice thing, when you go through Oracle to get to Hadoop or to get to Hive or to get to some other NoSQL database, not only can you use in-memory, partitioning, things like that, but you're using that security of going through Oracle as well. And this is making it, maybe 100 times faster. It depends how faster your in-memory is, but it could be faster than that. So external tables do not support, though, in-memory at the column level, like regular in-memory. You can just put one column into memory. External tables have to put the whole table into memory. Now, when you build an external table, you could just grab the portion of data you want anyway, so it's kind of irrelevant to some degree. But here's how easy it is. We've never created an external table. Let's say I have some big Hadoop data set of some kind. I say organizational, external, and I map out the columns where I want those, where it's terminated by, where the fields are terminated, and so on. But to add in memory, all I gotta say is in memory. That's it, one line. So if you already have an external table, one word, that's it, in memory, puts it in memory. And then here's an example. I could check the external tables, and this tells me, yes, it is in memory. I can also do inline external tables. So instead of creating a table, inserting the values, dropping the table, I can do that inline, if you're familiar with inline queries. I can now do that insert select from external specifically without doing all that. No need to pre-create that external table that you're just going to use for a one-time use anyway. Standby no logging tells the database not to log operations that qualify to be done without logging. So in the old days, if I said no logging, now all of a sudden whatever I was doing, it doesn't end up on my DR site with DataGuard. Now DataGuard says, hey, even if somebody does no logging, I want you to move it over there. There's two different modes. One for load performance, where it gives you those non-log data changes. Minimum impact, and the non-log logs are resolved by the managed standby. Or no logging for data availability, where the standby will wait at the commit. Now, it could slow down what you're doing, because it has to also go and commit on the DataGuard side as well. So basically, it's giving you an option to do it either way. Do it right away or delay it. But either way, I don't lose them anymore, which is nice. Partitioning, I don't know if you noticed that in 12c R2, I can do a split partition online. Oh, nothing about a merge partition online. But in 18c, oh, they finally got that merge partition online. Just a thought. And there's just an example of how to merge partitions if you're not familiar with it. Oh, and a good point. I can also do an update indexes on this as well. So those indexes will remain usable during the move operation, or the merge operation, rather. I could also, in Approximate Query, now do top N. So you saw some of these that were in 12c. Now I can do where I can do an approximate count, fetch first 5 rows, or rank something, order by approximate, and then having approximate. So finding the top number of rows with approximates. But the short answer is I get to use a lot more functions in a lot more places in 18c. Very well worth it. And one of the biggest uses is, what are my top 50 customers in each region with their approximate spending? Just a way to answer those type of questions. And here's an example, top 10 values. I'm going to do the approximate sum of salary, but I want the rank, and I want it a certain way, and I want the top 10. Very, very helpful. But the biggest help with approximate, and I told you there was a big benefit in the background. Now I'm going to actually show you what that benefit is. And that is, notice it's using a gig of temporary without the approximate, no temporary with the approximate. Oh, sorry. And then here, I'm using over a gig, about 1.1 gigs to sort, and then that goes down to only 59. So I'm just using a lot less resources. So not only is it tremendously faster, but it's a lot less resources. So I get benefits in multiple places. Oracle also built something called Polymorphic Tables, where I could take multiple pieces of something, be able to display it in this nice, looks like SQL query way of doing it, but each of these columns are not coming from the same table. They're coming from all kinds of data sources. And you might look up a presentation on this because, you know, there's people that give presentations with 300 slides on just this operation. But basically, any kind of table that I want to build, it'll accept. And then I'm going to build some kind of sophisticated knowledge. Maybe it's AI, maybe it's machine learning. And then I'm going to take pieces of these different places and I'm going to put it together with these result sets. And here's just an example of it. You know, I'm looking for somebody's credit risk score, but some of it's coming from a table, some of it's coming from XML, some of it's coming from JSON, some of it's coming from some analytics report. And then I'm piecing that together by putting the logic in there. And then I'm showing it to somebody that they just selected from a single table. And you can see the query here. So a way to build sophisticated algorithms under the covers that to the user it's very simplistic, or the manager that wants to see that credit risk score. Very, very powerful. Oracle has also done a lot with sharding. There's sharded rack as well. And one of the things I thought was pretty cool is you could go across shards with statistics. I don't cover shards in here because it's kind of a topic all for itself, but if you're interested in sharding, Oracle has some great talks on that. And they also have sharded database with spatial data types, which they didn't have previously. Another nice 18c feature is private temporary tables. So instead of having this persistent table definition that I'm sharing, I have a private table definition for the different users that are out there. And this just shows that, you know, global temperature table, you know, all sessions see that metadata, whereas, you know, with a private temporary table, just that session is going to see that. You can see some of the other stuff I just put in there for you. Oracle on 18c also built an Oracle read-only home. So, you know, as I'm patching, updating the database, you know, I just want to change one Oracle home that many people are using, I could build this, notice the acronym, read-only Oracle home, control, enable, read-only Oracle home, control, help. So it's made it pretty basic. But in addition, also on 18c, I could do an RPM, if you're familiar with that as well. And then the big benefit to read-only Oracle Home is, you know, this line right here. The database tools, processes are under the Oracle base path instead of the Oracle Home. And then the read-only Oracle Home is now going to separate that software from all this configuration information. It's going to help you with version control a little bit too. Oracle Express Edition will come out for 18c in 2018. It's expected in the calendar. If you saw my Twitter, we would have seen more on that. I might show that if we have a little time at the end. Some other things in 18c, official Docker support in 18c. Some of the other ones you've seen already, I've shown. Snapshot Carousel is one of my favorites. Passwordless schema creation, that's a new one. Not just star schema, but also Snowflake. That's kind of nice. If you want to play with 18c, you say, gosh, I wish I had on my resume that I worked with 18c. Rich has it on his. Why can't I do that? And the answer is you could do it right now. You could do it when this session is over. Go to livesql.oracle.com, and you could go check the version here. And guess what it is? It's going to be 18.1. So you could actually try out some SQL in version 18. So that's kind of a cool little site. It's kind of fun to try out the next version, you know, or you can do that in the cloud as well. Now I'd like to jump to something new in 18c, which is called Autonomous Database. And specifically, I'm going to look at the Autonomous Database Warehouse. But before I do, first of all, I want to show you, you know, what's the goal here? The goal is 100% self-driving, where a DBA doesn't have to run that. Now, I probably can't do that for a lot of the main systems that I have, but there's a lot of small databases that nobody has time to manage. So how about I use them for those? And then I'm going to look at Oracle's new security. So is this going to replace me? You know, Pepper the robot, Well, just to let you know, I can interface with Oracle Virtual Private Assistant, and I can integrate Oracle to a robot like Pepper. That's a different talk of mine. Maybe Francisco will have me come to robots in Oracle sometime, which I have a talk on. It talks about chatbots and how you use robots. This is what you basically want to focus on after you get things like 18c running in an autonomous database. But really, if you look at this, it's really to make your life easier. You know, Penny Averill, says this is not going to get rid of the DBA. It's just going to change how the DBA works. Less time on infrastructure, patching, upgrades, availability. Maybe not tuning, because you better tune it before you move to the cloud. If something's really slow or you're giving too much data and you don't need all that data, well, the cloud's going to cost you a little more, right? But once you do that, maybe tuning before you move it and maybe ensure your data sets are smaller, then you can focus on design, analytics, policy, most importantly, security. But at the end of the day, I'm just going to make sure it's tuned before it gets to the cloud. Did I really need to send 15 terabytes to this autonomous database? Maybe I could have made that much smaller and I only needed 100 megabytes. Maybe I needed only a gigabyte. Who ensures the vendor's charging me correctly? How about backup and security? Is it right? Did it work? Did I try it? It builds the policies. And the answer is DBA is going to do this. So in the future, and there is an on-prem 18c. It's not only autonomous, just to let you know. I've heard people say it's only autonomous. It's not. But the on-prem DBA is going to work on the on-prem 18c, but they're also going to make sure they're ready for that other 18c, which is autonomous, to help save them time in the future. But the key, in my opinion, in the future is become a data manager, not just a DBA. Companies need you to leverage their data. Data, a lot of people will say, is the new oil. How I leverage that information and how I can help the business leverage that information is what's going to give me a lot of value. So now I have to go to a lot more places and a lot more, maybe even databases, to be able to give somebody the application they want. And if you look at this diagram, what's the 90% of the knowledge you need to know? And the answer is Oracle. This is the hard part, is right here. The other part is a lot more shallow. Oracle is very deep comparatively. Autonomous database, Oracle guarantees 99.995%. As long as I have a standby. If I don't have a standby, 99.95%. But it'll patch itself. It'll back up itself. It'll upgrade itself. So how do you patch 100 databases if you're only one DBA? You don't. You make a lot of them autonomous so they can be patched by Oracle, and then focus on the databases that matter a lot. Here, an example on speed. Oracle compared themselves to Amazon Web Services, substantially faster. About 15 times faster. But when the cloud is 15 times faster, it's a lot of times 15 times less expensive if the price is the same, per a certain amount of work done. So speed in the cloud means cost savings. And then Oracle is coming out. They have the Data Warehouse Cloud Service out now, but they're going to have OLTP. They're going to have Express, NoSQL. They're also coming out with analytics as well, and a couple others shortly. It's actually, very soon. How does it look? Well, basically, I define these tables. I load the data. I run the queries. And here's an example of just, where I'm looking at data in different ways. And they have a worksheet and notebook that you can use for this. But Oracle shows you just a few questions, and here's the actual screen. I think Oracle said 4 simple questions. Looks like more boxes than 4, but it's very fast, 30 seconds. I built it. And when I'm done, it looks just like the cloud now, if I've ever used the cloud. Very, very similar, except now Oracle's patching it. Oracle's backing it up. You just have to make sure I do it up front. And then this is George Lumpkin, is one of the architects there with Yasin. But you can see, some of the impressive things that you can build and it's automated. I'm going to use analytics to go to it. But the other piece of the autonomous database is machine learning. And Oracle is starting to build a new secure technology inside using things like machine learning and AI. I'm going to pass that up. We look at things like Equifax, where all this data was lost, a tremendous amount of data. Look at Facebook, he's in front of Congress now. Why? Because somebody lost some data. Well, now violating privacy potentially. So Oracle said, let's use machine learning to go after, either phishing sites, malicious IPs, obfuscation, bad URL. And then we're going to put that together and start to put a data architecture to look at what those threats are. And Oracle's going to do that internally with machine learning. Then they're going to find out, is somebody browsing suspiciously? Maybe we boot them off there, out of the autonomous database. Or are they trying to hack into another account? Maybe we boot them off there. Or maybe they're going after some security table. Shouldn't be doing that. Let's knock them off there. Or maybe they're trying to pull data out. In this case, they're pulling data out to an Amazon bucket. And they shouldn't be. And notice there's a data score for each of these levels. You may get them out of there by 63, but this is just an example of different ways where it's increasing. And then you have a nice little dashboard Oracle's built for this as well. Here's the last line of defense, though. It used to be IT was so magical. This is what your business needs again. They need what you use when you leverage all this data and you become a data administrator, not just a DBA. They want you to create this magic again, not overbearing and certainly not toxic. As things accelerate, it's going to be a lot like the Twilight Zone. And I don't know if they watch the Twilight Zone in Australia. That's kind of interesting. I never asked. But if you don't, you should definitely see it on YouTube. But why is it like the Twilight Zone where things are, well, I can go to here. If you've never watched it, it's you unlock the door with the key to imagination. Beyond it, another dimension, a dimension of sound, dimension of sight, dimension of mind. You're moving into a land of both shadow and substance. Things and ideas you've just crossed over into the Twilight Zone. It's this futuristic place. Well, guess what? It's here. Why is it here? Because we went from 4-bit to 64-bit. And notice the addressable memory as we made that move. Look at it, just growing so fast. I put it in miles per hour. If Windows was 1 mile an hour when I went to 16-bit, I got Windows. But when I went to 32-bit, I got the internet. And I'm going 65,000 miles an hour faster than Windows. And what am I jumping to now? 64-bit. Right now. You're about to jump to 300 trillion miles an hour. And what am I getting? Robotics, 3D printing, 4D printing. I'm going to jump to 128-bit. ZFS, just to let you know, it's already 128-bit operating system. But it'll be 5 trillion billion of miles per hour faster. That's what these numbers are when you make each jump. And the feeling that Windows was all of a sudden, wow, that was something. It's because of 16-bit. And then the internet, wow, that was something so much bigger. That was because of 32-bit. 64-bit. I mean, you're starting to see things like this. Is like the Twilight Zone. It's wild. It's going to happen with 128-bit. We'll see, because you're going to build it. In 2013, the Gartner Hype Cycle, this shows what technology's coming on, and then the shape and color of things. How long is it going to take to get all the way through this cycle? Some things take a long time, like, quantum computers pretty slow, more than 10 years. But then some things are faster. And then people are talking about them like crazy. So in 2013, it was all about big data and Internet of Things, stuff like that. But then the people are like sick of them, and it goes down in this trap of disillusionment. But then eventually it becomes productive, like predictive analytics. But in 2013, this cycle was all about tech stuff, if you notice. But in 2015, all of a sudden, it started becoming about robots, autonomous vehicles. It's really a robot car, right? Internet of Things, starts to talk to each other. Connected home. Smart robots, human augmentation start coming on. I do have some tech, hybrid cloud computing. That's 2015. Look at robots. Go to Honda. They'll take you to your meeting. Stop, go get coffee. The robot will take you. Oh, how about you get a surgery on the way over? Oh, that appendix needs to come out? We'll get it on the way over. Okay, they don't have that yet, sorry. Just kidding. But they could carry you to your meeting if you wanted to. It's a robot that moves people from a bed to a wheelchair. These are things already there. Pepper the robot. You could use Oracle to set them up as, here's Pepper the hostess, different places. Here's an example of, checking in with a robot hotel. Here on the bottom right is a robot hotel. You could check in with the dinosaur or with her. Or you could just check in with the screen. See how boring that is compared to the robot, though? Interesting. But the world's going faster and faster. Don't become too attached because it's going to disappear. Look at Star Trek. This used to look advanced. Now if you came out with this phone, that Captain Kirk has, you'd be laughed out of business. The new normal. How many people went on Amazon Prime yesterday? Crashed as soon as Prime Day began. How about that? I went there and it was like something went wrong. And then a little while later, oh, sorry, something went wrong on our end. Oh, sorry, something went wrong on our end. It worked so intermittently. Maybe it's just because they're real popular, though. Where are we heading toward? Are you going to become the machine? Is the machine going to be combined with you in some place? Is it going to be implant technology? I mean, look at this guy. He's got where he's a tattoo artist, and his arm has become his job in some way. And then this guy, his arm rotates 360 degrees, and he can hold things very, very in a strong way. Some people could, you can connect your mind to this. This is more into my robot talk. But at what point does man interface with robot? To compete with robots, you have to have implants. I always thought a great quote, Pope Benedict, talked about, in the future we'll be able to genetically engineer human beings, and they're going to have things like implants and stuff like that. He said, at what point are you manufacturing humans? And is it a person anymore? And is this taking away more of life than it's giving you? These are the questions we're going to have to focus on in the future. But as I said, this is all about what's important now. And the answer is 12C, 12CR2. Once you get those features in, then start to focus on 18C. Well, what do I want there? And then 19C, very important, because remember, that's where I wanted to land. And then maybe let's look at those databases that I don't want to manage. I'm going to let Oracle patch those. Autonomous Data Warehouse database in different ways. But never forget, you're here floating on this planet. I'm here and you guys are over here, in the other hemisphere. But we're stuck to this planet floating around, communicating right now, and all these other planets are floating around. What are we doing with this incredible opportunity you have in life? If you put that solar system into the galaxy, look how impressive it is. We're just super tiny here. We just started to see what's out there. And if we put that galaxy out in the universe, oh my gosh, the galaxy is only this big. How amazing, is it that you live in this time? 13.7 billion years went by, from the Big Bang till now. And here you are, 13.7 billion years later, floating around in the universe. Why did God put you right here at this time, to do something big maybe? This is where things are going. It used to be disconnected dark age, there's a mainframe there. We started moving to using digital. Then wearing digital. Oh, I got it on my watch. Maybe in my eyeglasses in virtual reality. To implanting digital. Oh, I'm using my arm for my job. And eventually it'll be the hive mind. You build a nice hive mind. I'll hook right into that. Some people say, I just want to make more money. I don't care about any of that, Rich. And I say, well, guess what? GDP over 10,000 years, you are in the right place at the right time. You literally are right there in all of history. But what are you doing with it? Make a living by what you get. Make a life by what you give. You know, I came here from Chicago. I'm actually in our home office, which is in Dallas. But I wanted to make an impact in Australia because Australia made a big impact when I went out there a couple of times. I appreciate that. But never forget success. You know, it's a lot of things: hard work, rest, late night, struggles, failures, persistence, action, discipline, courage, doubts, change, criticism, disappointment, adversity, rejection, sacrifice. And then all of that suffering adds up to success. People think that's all there is the tip of the iceberg. But you do a lot if you want to make an impact. You live in a time where you can make a bigger impact than anyone else. Make sure you take the time to make that impact. Thank you. And you can see Oracle. I don't think anyone's going to catch Oracle. They're in the lead. I think they'll continue to get better. I think with security, they're going to get better yet. Oh, there's some great Oracle aces and eights director. That's kind of cool. I was going to show you one more thing. We'll see if it actually works. Probably should have stopped there, but hey, what do we know, huh? Let's go to Twitter. I go to Twitter and I search for Rich Niemiec. It's like it had just clicked on me there. Okay, that would have been easier. I'm going to look at these tweets. You just saw Francisco talking about, oh, don't miss Rich's talk on APAC. And in Chicago, we'll be putting Sean Tucker, that flies the Oracle plane there. But I was going to show you some of the other things that I've been shown. This is a great one from Scott. Oh, you know what? I bet I gotta go over here. Hang on, hold that thought. But it's not showing that, is it? Francisco, do you see Twitter right now, Francisco? Francisco. He's like, oh, I'm not watching anymore. I'm kidding. Let's see, webinar. Oh, sorry, wrong one. Now, like I said, I shouldn't have. Okay, yeah, so you're still on the talk. So I'm going to see if I could change my screen share from this. I'm going to show you this one. It's going to be how it's going to be with Autonomous Database. Let me show you this one instead of Twitter. This is pretty good. But this is it. You're going to be the DBA. And you're going to be driving like you're driving in a self-driving Tesla car. Oh my gosh. Oh, they're managing the tables by themselves. Put me back where I can run my own database. I don't want Autonomous Database. Oh my goodness. He says no. Let's skip that. I don't think you can see it. He's like, no, Rich, we're not seeing that. I see books. Okay, so you're back here. But anyway, Autonomous Database. Look it up on YouTube. The grandmother in the autonomous car, and she just can't handle it. She wants to drive herself. It's scaring her to death. That's how it's going to be when you build your autonomous database. So keep that in mind. Get a great book, upgrade your 12C, and watch a few Twilight Zone. That's a good one right there. I want to thank Francisco again for helping me. We put on this presentation. Without him, we wouldn't have been able to do that. Thank you for coming, and please have a great day. And with that, I'm going to say goodbye, Francisco. Anything else you want to tell us, Francisco? You could text it to me. Oh, he said could see the video of the grandmother. Okay, you can see it? Yes? Sounds like you did. So I did get it. Maybe I can go to that Twitter page. Oops, sorry. But anyway, just having a hard time with that that autonomous database, and I think that what's going to happen is you have that same problem with that autonomous database, So thank you, and thanks for coming, and you guys have a great day. And Francisco says you too. Have a great day. Thanks, guys. Bye now. And I'm on time. Oh, it's 3 minutes early. Thank you, Francisco. You guys have a great day. With that, we'll end the event.